Okay, so we're going to be making the bricks put into some kind of grid. Right now they're just random, and that's not how Brick Breaker works. So I would like to just show you, first of all, why they're random, and then talk about the code that would organize them, or just the code that puts things into grids in general, and then like merge them together. So first of all, the reason they're random is if you go to the brick class, you can see that the constructor is what puts them into a particular place when they begin, right? And the reason why they're random is because we tell them to be random. We say that their x and y coordinates are going to be randomized. We're going to give them whatever, like a random number for those values. So that's what makes them random in the first place. So the answer to like how do we put them into a grid is basically, well, we have to give x and y here different numbers. What makes that hard, though, is that the constructor has no idea to know what brick it's making. Is it making the first brick? Is it making a middle brick? Is it making the last brick? So that's not going to be the only place we have to put some code in. We have to put it also, if we go into the main tab, we also have to put it into our setup. Here's our setup, and this is the code here that goes and makes all the bricks. Like it calls the constructor. In my case, I'm doing it 60 times, apparently. So there's going to be sort of a collaboration there, where we're going to have some math done in here, and we're going to send that math along to the constructor in here. So that's where we're going to go eventually with this. First, though, before we go down that road, I'd just like to review how do you make things into a grid in general. So I'm going to make a new sketch, and we're going to put a grid of circles onto the screen. And we did this way back when, in the beginning of January, when we were like, oh yeah, how do you make a grid of circles? Because that was one of the cool while loops that we did to make patterns and stuff. We made a checkerboard, things like that. So we basically had some x and y variables, and they just started at 0. I think I could just set them at 0 like this. And then we had a while loop that would over and over again draw some kind of ellipse, and I'll leave the condition blank for a second. And I think it's like this is the most important part of the lesson right here. Well, there's two parts. First, just understanding how something gets put into a grid, and then there's understanding how that connects to the classes. So this is not something for you to type down right now because this is just a separate sketch, just something to help you understand the math again. And you might already remember it, I don't know. So here's me going to be drawing the ellipse at x and y, and it's going to be like 50 by 50 or something. Doesn't really matter what size it is. And then we're going to sort of draw the next ellipse. So to draw the next ellipse, the while loop's got to come around and draw it. But if we just do this, let's say like just put in some random, well, y is, actually I don't know. If we just put this while loop and just did this over and over again, the ellipse would keep being drawn at the same place over and over again. So how do we make the next ellipse drawn to the right of it? Like what number would we change to make the next ellipse go to the next one? It would just be x. We'd just say x equals x plus whatever number we want. Let's say 50. And if I'll put in some random, this isn't the final thing, but I'm just going to say, well, x is less than, well, we need a size, I guess, sorry. Let me put a size in. Let's say it's 800 by 800. We'll keep on going as long as x is less than 800. That will produce a bunch of circles along the top. And again, don't type this in because it's not what we need exactly, but I'm just trying to explain how this works. But hopefully it makes sense why this is a row, right? We're going to draw one ellipse. It's going to start at 0, 0, and then we increase x by 50, so then when we go again, the next one gets drawn to the right. And if we were to exchange this number instead of 50, what if we put in like 100? Well, how would it be different? So then they'd have like a bigger gap between them, right? Because we're increasing by 100. And it looks like a perfect circle would fit inside of there because they're 50 by 50. So that's one aspect of it. I'll put it back to 50. The next thing is, though, how do we go to the next row? How do we go down? So we don't want to go down all the time. If you did that, like watch this. If I said y equals y plus 50, then every circle would get put on a different row, and you get a diagonal of circles, which is, oh, this is kind of cool, but it's not really what we wanted, right? We want a grid. So we don't want to do this every time. We just want to do that when we get to the end of the row. When we get to the end of the row, we want to go down and then back to the beginning of the row. So that's where the if statement came in. And I'm going to get rid of this condition because it's not the right condition, so I don't want anyone to get confused by that. But basically, after we go over 50, we should check to see if we got to the end. So we can say, hey, if x is, whatever, greater than 100 or 800, let's say, because that's the end of the row, then we should go down by 50, but then also reset x back to the beginning of the row. So that's what allows us to kind of, this always happens. We're always going to the right, to the right, to the right, to the right. But then when we get to the end of the row, we go down to the next row and then back to the beginning again. Kind of resets us. So then what condition do you use? Well, you can't use x. If you use x, x never really gets to the end because as soon as it gets to the end, it goes back to the beginning again. So then we use y because y is always increasing. So we can just say, while y is less than, I'll put less than or equal to 800 as our condition. So then I'll stop when it gets to the bottom row. And that gives us our tiling of circles. So each time we're drawing a circle, we draw the first circle, and then the next circle we go over by 50, and the next circle goes over by 50, and it keeps on drawing all those circles, and eventually gets to this last circle, and then it does x plus plus again, so it goes over here, and then that if statement triggers, which brings us back to the beginning and down one row. And then it continues on again, draws another row, and eventually gets to the end and draws out all those rows. So that's the story there. I wonder if I could, can I do this? Let's see. I'm curious to see if I could animate this. This is perhaps a foolish thing to do on a video. It's going to go live on the internet. Let's see. I'm going to turn this into just a draw function. I think I need some voids in there. Coding on the fly sometimes is dangerous. I wonder what will happen. Let's put out like, I'm going to put the frame rate really low. Frame rate 10. And I think you can see like this code in action. I don't know. Let's see. Does this work? Yeah, do you see? Oh, that works. So there you go. So that's sort of like without the while loop, if we put the draw function as our loop, then we can kind of see how it works. So you can see how it's always doing this x equals x plus 50. That's why it's going across. But when it gets to the end, this if statement triggers, and so it goes down and back to the beginning again. And it keeps on going. And because it's in the draw function, it'll never end. It'll just keep on going. But that's basically what we want to have happen as well for our bricks, right? We want that same sort of pattern. We might want to switch it up a bit. We might want to make it a little bit spaced out. We might not want to start on the edge. We might want to start a little bit in. So we'll explore all those things. But right here, this part here, let me delete this and show you sort of this part. This is sort of, actually I'll put the ellipse back in. And if I zoom in on this to really like amplify it, like this here, right here, is the crux of the code for making it in a grid. There has to be some kind of loop surrounding this, but this is how we're going to sort of create that grid-like structure. So I'm going to now go over to the actual Brick Breaker project, and we'll take a look. So what I'd like to do is replace this with that same kind of XY variable. So I'm going to make an XY variable in my main tab. So here's me going over to the main tab. And it looks like I've already done it. I called it grid X and grid Y. And the reason why I called them that is because I'm sort of planning a grid. So these variables are going to be used just for planning out the grid. They're going to be the exact same variables as the X and Y in our previous example. They're going to do the same kind of thing. So you're going to have a grid X equals grid X plus 50. And if grid X is greater than whatever number you want, grid Y is going to increase. And grid X will get reset to 0. It's the same variables. I just didn't want to call it X and Y because we got a bunch of things named X and Y already. So I called them grid X and grid Y to differentiate from all the other X and Ys out there. So the secret sauce to this is that in the brick constructor, I'm going to be setting X to not a random number, but to grid X. I'm going to set Y to grid Y. That is going to be the secret to the communication. That's how the brick is going to find out where to go. So I just made that change in the constructor. And this doesn't really do anything yet. This just means all the bricks will all show up at 0, 0. But we have an opportunity now to change grid X and grid Y in that loop that goes and creates all the bricks. So that we can create the pattern. So just to demonstrate that it's dumb right now, like there are, I guess, 60 bricks. They're all in that corner up there. But now, if I go to my setup, here's my chance. I can actually change grid X and grid Y each time I'm making a brick. I'll make a brick, and then I'll change grid X. So watch this. I'll say grid X equals grid X plus 50. So now each time I make a brick, I'll make a brick, and then I'll change grid X. So the next time I make a brick, it'll be 50 pixels over. I'll just demonstrate that that works as advertised. See how you get the same pattern as we had before? Except that now they're bricks that actually break. They're not just circles. They have all that logic built into them from their behavior functions. So you can see I can pop them, and we've made already a reasonable game as a result. But we don't want to stop there. We want to have like the next row. So then we are going to go down, just like we did in our if statement. We're going to have a similar if statement. So here's our old if statement. If we get to a certain point, then go down and reset. So we'll do the same kind of thing. And again, I think that these numbers aren't the right numbers for you, so you'll do some experimenting with this, but hopefully the idea is clear. So I'll say if grid X is, I'll just say greater than, what's my size? 800. Then I will set grid Y to be 50 more, and I'll reset grid X back to 0. So if I run that, we'll get more bricks. And now you see they're in rows. You might notice, though, that it kind of randomly stopped in the middle of the row. What? Well, I didn't keep going. So here's the story, and this is something that you'll have to plan out with some math. And you might need to get your calculator out or something. But the story is that previously in our other program, our condition for our loop was just like something like while y is less than like the size of the screen. It was like that. So our loop stopped when we got to the bottom of the screen. But notice what our new condition is. Our new condition is while I is less than 60. That has to do with the number of bricks. So it just happened that we got to the 60th brick. Like if you were to count all the bricks there, I mean I broke one, or there I broke one just now. But if you counted out the bricks, there would be 60 of them. And you could do the math, you could count how many there are. Like let's do it now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I probably could have divided 800 by 50 and got there a little bit faster. So there's 17. I have 4 rows of 17. So I guess I don't want to go to 60. I want to go to whatever 4 times 17 is. And I'm too lazy to go calculate that, so I'm just going to literally type in 4 times 17 in here. Oh, man. Life's good when you can get the computer to do math for you as well. There's one other change you have to make. Don't forget, though, if you change this number, you do have to go to your game function and change the other while loop condition as well. So that should also be 4 times 17. And I might have done that math wrong. Let's find out. Because, well, I don't know. Let's see. Oh, it did work. I guess I was right. So see now how we got complete rows? So I just mathed it. I just did the multiplication. Now I did ask the class to do something in particular. I wanted there to be some space at the top and the sides. So that was a requirement for your grid as well. So don't start at 0, 0. And don't end at like 800. Make it so there's some space, because the best thing about Brick Breaker is when you get the ball up on the top and it's like bouncing around, and you can just like take your hands off the mouse and everything, and it's just bouncing, bouncing, bouncing at the top, like in this space up here. Because then it's easy time. You know what I'm talking about? That moment when you get it up there is like, oh, it feels so good. So I'm going to answer the phone, but I don't think I have to put that in the video. I think that's going to be probably a good, just to issue that challenge to everybody right there. But I'll help you out as you're going forward with that. All right, thanks everybody.